To find the excluded value, we want to remember what excluded values actually are. So I just threw the definition up here. It's the value that's going to make the denominator equal to 0. If you remember in math, that's the one number you can never divide by. Anything divided by 0 is undefined. So we try to avoid having that happen. So if you're asked to find the excluded value, here's all you have to do. You look at your denominator, grab the denominator, write it out here. We know that denominator 5x cannot equal 0. Once you have that statement, then it's as easy as solving for x. In this case, we would divide by 5. So we have x cannot equal 0. And that is our excluded value for that first rational function. And if you think about what would happen if you plugged a 0 back in for x right here. Well, 5 times 0 is 0. And 6 divided by 0 is undefined. So 0 is the value that we have to exclude for x. Alright, so again, our next example, to find the excluded value, just grab your denominator. Go ahead and say that x plus 8 cannot equal 0, and then solve for x. So we'll subtract 8 from both sides. So x cannot equal a negative 8. And again, if you look at, the problem, if you put a negative 8 in for this x, negative 8 plus 8 equals 0. 7 divided by 0 is undefined. So we will exclude negative 8 from all the values that x can equal. Alright, so those two are pretty basic and straightforward. Sometimes you can come up with a number just by looking at it. But again, taking the denominator out, that's something you can do on every single example. For example, this next one, if you grab the denominator and say, alright, x squared, oops, not plus, x squared minus 3x cannot equal 0. So for this whole chapter on rational functions or rational expressions, when in doubt, factor everything. Because of the x squared and the 3x, you have x's in two spots. You cannot just solve for x like you normally would, like the examples above. We have to actually factor this out. So wherever you see, factor out, think about, in this case, GCF. So we could take an x out of both terms, and you're left with x minus 3. So there's our equation. Let me make some more room. So now that it's factored, you're going to take your factors and say that first x does not equal 0, and the other x minus 3 does not equal 0. Solve either of those for x to figure out what your excluded value, or in this case values, we're going to get 2 of them, will be. So the first one actually is solve x cannot equal 0. The second one, if you add 3 to both sides, you get a positive 3. So x cannot be a 0 and a 3. Those are the two numbers that, when plugged in for x, would give you 0 in the denominator. Alright, our last example up here looks a little bit trickier, more going on. Go ahead and grab your denominator. X squared plus 5x plus 6 cannot equal 0. So the entire denominator cannot equal 0. Now, this is a trinomial, which means we're going to try to factor this. We want to look for factors of 6 that add up to your middle term of 5. So it multiplies to 6 but adds up to 5. A positive 2 and positive 3 will be our factors. So we'll say x plus 2, x plus 3 does not equal 0. And then you take each factor and write those little mini equations. If you take each of those and solve for x, we'll subtract 2 on both sides, and then we'll subtract 3 over here. So in the end, x cannot equal a negative 2 and a negative 3. X can be any other value except for those two. Those are the two values that would make that rational expression equal, or undefined, because the denominator would equal 0. So excluded values, if you just remember what it means, it's the value that makes the denominator 0. So just grab your denominator, rewrite it, not equal to 0, and then solve for x, and that's how you'll get your excluded values.